got an ambitious program planned for today. We've had a group of instructors that have worked very hard on this to try to help give you more information about the skills that you need to teach the GED math. We're also very privileged to have Paige Scott here today, who's a college math instructor. Paige, would you stand up so they can all put a face with a name? She's going to be talking to us a little bit today about what she does in regards to teaching beginning college students what are essentially the same kind of skills that we're going to be teaching, or that we do teach our GED students presently, so that they can pass the new GED test, particularly the math one. So we're going to be concentrating on math today. We're also going to have a portion on the extended response program, so I think that's going to be real exciting. Before we get started, I would like to ask Phyllis Kelly. She's going to come forward and talk to us a little bit about the CACC Summer Conference. I don't know whether you all know it or not, but our program is fortunate in that CACC, the State Adult Education Association, we have 3 individuals from our program that are members of the board of directors. Ms. Kathy Watson is a member from this area. Ms. Rita Cream is a member of the board from the Alexander City area. And Ms. Kelly has just gone on the board as an at-large representative. So we're real excited about that. She wants to talk to you a little bit about CACC and the summer conference.
Good morning. Good morning. It is great to see all of you today. As a CACC board member, I want to stand before you today and ask you to please consider attending this year's summer conference. It will be held July the 8th through 10th in Montgomery at the Marriott Renaissance Hotel. The theme of this year's conference will be Adult Education Summer Conference, Adult Education Back to Basics. With the new computer-based GED test and all of the new skills our students need in order to successfully take and pass this test, we think it is important for us as educators to get back to the basics to make sure we are prepared to prepare our students to successfully take this test and move on from passing the GED to college and career readiness. We want every GED graduate to enroll in some form of post-secondary education or some form of job training. We're going to prepare you guys. We're going to do everything we can to provide professional development opportunities. If you have professional development opportunities that you want to see us take on, please contact a member of the board. I represent Region 4, which is Jefferson and Shelby County. But I can represent all of you also. So we're looking forward to having a great conference this year. I look forward to seeing you all at the conference. We are also developing apps, so stay tuned. We're going to have plenty of apps for you guys to download and to use in order to help prepare yourselves and your students to be successful. Thank you.
Thank you, Ms. Kelly. And I would like to reiterate, I hope you all will plan, go ahead and mark that date on your calendars. Essentially save the day. We'll be sending out more information about the conference as we move forward. Most of you got some information a week or so ago about the new GED manager, and I'm going to ask Nan Self if she'll come and tell you just a little bit about the GED manager.
The orange handout that you have is for the GED manager. When you enroll students to take the GED test ready, or if they're registering to take the GED test, there are several places that they need to mark to allow you access to get their scores. And this handout shows you several places, and they can also mark the college that they're wanting to allow to view their scores. If you know a student has taken, if they pass their GED, as soon as they pass, it shows up in ASAP immediately. So when you separate them, you can just put in ASAP as far as the documentation for that. If you have a student that's tested and you want to know what their scores were, you can email either me or Phyllis, and we can provide those scores for you. We are considered the managers for here. So you can, send me an email and ask what their scores were, or if they passed, especially if they didn't pass, they may not show up. If they're only taking 1 or 2 portions, they're not going to show up in ASAP until they've passed all 4 tests. Okay, are there any questions about that? This handout shows you several places. You can call me if you don't see it, but when you're registering a student, there's several places that they can mark. They don't have to mark them all, but they do have to choose the college also. If they're a student from Talladega, they can mark like our college and Gadsden State if they want to. They can mark up to 3 colleges. If they're in Columbiana, they may choose our college and Jeff State because if they're testing or different places, that way both schools have access. In ASAP, everything is really the same as it's been before. Students, if they earn a GED, they data match immediately. If they get a job or enter post-secondary, that's done quarterly. So it will show up there. So it's not done immediately. So if they get a job, you do not have to send anything in to me. It's data matched by the computer. Are there any questions?
As we begin the next part of our program, I want to start by saying that in order to help our instructors meet the challenges of the new GED test, one of the things that we have been really, really looking hard at is having some good software for you to use to help you and your students master the kind of skills that you need. And in that regard, we've done some modifications. I know that a lot of you have used ITTS software in the past as one of our predominant means of preparing students. ITTS is good software, but it did not get us where we needed to be for the advanced GED student. So what we have done, we have reduced the number of seats that we have purchased in ITTS. We've gone from, I believe, 200 and mid-250, somewhere around there, down to 150 seats. Now, in order to manage that, Ms. Kelly is going to have to go in and look at the number of seats that are being used by each class on a weekly basis. And if we've got a student that's not attending and they're taking up a seat and we're over the 150 or close to it, she's going to take that student out. There are 2 ways that we can manage ITTS, and that's to separate a student, which you can do, and to inactivate a student, which only Ms. Kelly can do. And so one of those 2 ways, we're going to keep it down below 150. So what are we going to do with the additional number of students that we're taking out of ITTS? We are looking at a variety of different and new softwares to use. The Aztec software was promoted to us as a good software that would help our students prepare for the GED. But we don't typically just take folks' word for it. So we field tested the Aztec software in Ms. Linda Parris's class, and she found it to be an excellent software and that it really is targeted well to help our students prepare for the new GED. So we have purchased seats for the Aztec software. We only purchased, I believe, is it 25 seats, Ms. Kelly?
It's 20 consecutive seats.
20 consecutive seats. Now what the way that the seats are managed in Aztec is different than the way that seats are managed in ITTS. In Aztec, what 20 consecutive seats means is that we, at any given time, we can have 20 students in Aztec working. Aztec is primarily intended to be a resource for that student that is at the ASE low or ASE high level. And Ms. Parris is going to talk to you a little bit more about that. We have made the Aztec software available in Ms. Parris's class. She has taken a number of her ITTS students out of ITTS, put them into Aztec, and they're doing well. And I believe Ms. Melanie Vesey has also been piloting. So what we're going to do today, we're going to spend a little time, and Ms. Parris is going to come and talk to you about how you can get your students into the Aztec software. Now, we're also piloting a software for the mid-level student, kind of the lower middle-level student, called Think 60. And that's being piloted by Ms. Carol Lambert and Ms. Rita Cream. And they've not yet finished their pilot program. Ms. Parris, are you ready? No. Are you ready?
You have a handout that looks like this. Okay, if you look at that, I'm just going to show you how to get on it, how to get on the program, how to put students in, and then what the students see. And at the end of it, it's first thing is educators and administrators how to get on the program, and then how the students will go in. Let me show you what it'll look like when you type in. The website is learn.aztec software, and Google works the best. So you'll go in through Google to do it. But as an administrator or an educator, I'm just going to kind of just show you what it looks like, and then the directions how to put students in is there, and the last 3 sheets is all the material that's covered. I would say that the GED on ITTS, they need to be familiar with A level from the ITTS to pass the GED. And I would say that this Aztec program is for your fast track students, the ones that are above 9th grade, that are getting ready to actually take the test, because it is hard. It goes with the skills that are on the GED. Sometimes I think it might even go a little above what the GED will actually ask them. There are some math terms in there that I've had people that have taken the GED and said, we didn't have any of that. But then somebody else said, well, yeah, that was on there, but maybe it was in science instead of math. So it's pretty good. It's all those things that we don't know how to do, that when we saw the GED and we saw all those math skills that we didn't know, you can learn them in the Aztec program. So if anything else, it's good for us. So if you'll get on it, Phyllis is going to eventually give everyone that has students that are higher level the access to it. And then you can put students that you think would benefit from the higher learning. Now, if you've got the students that are still reading at 4th grade level, it's going to be too hard for them. They're not ready for it. They need to be in ITTS getting that level up. And when they get to A-level scores that are decent, put them on Aztec, because it's got test ready practice, even in the reading. It's got essay practice in the reading. She gave us so many keys for the Aztec test. It is in the Aztec program. At the end of the subject, it's got the test, and that's the same test that they got the key for. So once the student is in it, they can take those tests. One thing they did do is they split if you had him to take the Aztec test from the vouchers that she gave us, they split the Aztec test in language arts with the essay and made the essay separate from the test. So they could actually take the essay test without taking the other. So they did the same thing in social studies, and they did the same thing in science. So the essay test is totally separate. All right, to go in as if I can do this, you're going to click Educator Administrator. This screen will come up. This is where you put the name that she gave you and the password that she gave you to get on as an educator. So I can do this. Okay, and then my password. See how slow I am? Okay. Okay. When you come to this site, you're going to go into management and fix a tag for you. This is where you'll put your class. So see, I have, this is how you add a tag. I put my class. So if I want to run a report on my class, I go right there to do it. All right, and then you go to your account, and you set up your password, which you already have, and your role. Let's see, I think you do it right here. No, that's what we do. Anyway, you set up your role as a teacher. Just a minute. Okay, go right here to user. This is really good. You put. This is all students that are in it, but your class will show up under you when you tag yourself, okay? you can go to reports. After you put your students in, I'm going to show you how to do that in just a minute. If you tag your class and then ask it to run a report, it will do it. It will do just the students in your class. There's a student activity detail. There's student logins. It will tell you who logged in your class that day. It gives how long they stayed on the program, and that's the main reports that you would want. And it tells you what activities they did. Okay. You want to set yourself up as a grader, and if you have a student to do an essay, it actually will show up their essay. You can grade it. Now, if you know how to grade it, it's the chart that the GED uses to grade it. With the 3 rubrics, you can actually grade it and give them a score yourself, which I have not done yet, but that's something we'll work on in the future, and we'll practice that later on. And then you can give them, it can be added to their test score. And it gives you the essay on should college athletes be paid that was in the Aztec test. And it tells you how to grade it. You can also copy and paste it to a Word document and run a copy of what they're responding. So you can talk to it with them, okay? And then the way you put in the student is, where we go? Student, add a student, add a user. All right, you type, this is what you have to do. It's in these directions. You put their first name, their last name. You have to put an email. I would put the email that they signed up my GED with, but you can make up one. It does not matter. If you put an email that is valid and want the program to give them a password, you can do that. It will give them this crazy password like 4E7Y. Then they can go in and change it themselves. I did not do that. I just gave everybody in my class the same password because I'm the only one that's going to look at it, and I don't think it's anything that's going to need to be protected. And roles, they need to put themselves in as a student. Okay? Student. And then give them a password and then hit create the user, and that's where you put your students in. And you can list them all. If they're not on it, they're not using it. So only 20. Like if I had 5 people in my class on Aztec, and Melanie had 2 people in her class on Aztec, that's 7. If one of mine gets off, that's 6. You see what I'm saying? We can put 150 people in, but only 20 can get on it at a time. So, it would only be, probably at any given time, only 1 student in your class, or maybe 2, would be using Aztec at a time. And if they can't get on, it'll tell them. So you can say, well, we'll come back in 30 minutes and try again. All right, to go as a student.
I have a question.
What?
So really, as any of us could go in there and set all of our students up
Yes.
to be able, even though they may not be anyone you ever put in there, but when one reaches a level, it's just a matter of inserting. So
Yes.
all the paperwork's done ahead of time.
Yes. The only thing that I noticed about it is when I pulled it up, all the names. It's kind of like, what was the program that we had, Work Keys or something? One of the programs that gave all the names that are in there from our whole college. And then, but that's why you tag your class. And that way you don't worry about all those other names. I mean, it's got Melody's name, it's got her students, and it's got some of my students on there. But I'm only concerned about mine. So when I get ready to do reports, I pick the students. If I want to do 1 student, you can click them. Also, right here, before I get out of this, tutorials, it has videos that you can look at that tell you everything I just said. Probably tell you better than the way I said it. But you can go into there. It tells you how to set it up. It tells you how to grade an essay and everything, okay? And be sure, let's see, this was I hope I'm not logging out of the whole that's okay. Be sure you log out. It comes up, they put in their name, they put in their password, and it comes right up. And then they click on the program and go to work. In each subject, it has lessons, it has drill, Like if they're working on main idea, they can go to drill, and it just gives proper reading and answer question, reading and answer question, reading and answer question. And then it's got a test on every subject. Like if it's main idea, it has a lesson on main idea, it has drill on main idea, and then it has a post-test on main idea. And then it has other subjects, okay? And notice the math when you look at the content, because it's about the hardest of the hard math that we'll need for the GED. And she's going to help us learn some of that math in just a few minutes. Okay. You can email it to me if you have any questions about it, and I can probably help you.
Thank you, Linda. That was a great job. I think any of you that have ever had any experience with demonstrating software live off the internet, it very rarely cooperates fully. So I appreciate that. Appreciate you doing that, Linda.
Can I say one more thing?
Empowering. Oh, absolutely. I think we got a question in the back.
They can, if they work on it at home, I learned how to go in, and I will research this more, and I can send out an email, but they can go in and we can count the hours. I think before we've set up another class, like an online, and we can count their hours and print that out, just like it was the other program that we had. The ITTS, we can count their hours from home. So you can actually do that from here.
Right. Melanie, did you have a question?
I just wanted to add that there's also audio with it, and so they can put the headphones on. And if they think the screens are moving slowly when they don't have the headphones on, that's because there's audio with it. And then a little button will come up that says continue, or the next button will flash when you're ready to go to the next screen. So if they're wondering why it's going so slow, if they don't have the headphones on and listening to the audio, that's why. And some of the audio is extra. It's not exactly reading word for word on the screen. So I've told my students, listen to the audio too, because it's very helpful. And that's good for our audio learners too.
As a GED fast track teacher, Melanie, how did you find the content? Did you feel that the content in Aztec was going to be more helpful to your higher level GED students than the ITTS?
Yes, it's better GED prep, and the students I've put in it have really enjoyed it.
Right.
It's been challenging, but they've enjoyed it.
I want to encourage each of you when we, of course, we may not try to implement it before Christmas, but when you come back after the Christmas break, be thinking about implementing accessing the Aztec software for your students that are at the level that they would benefit. So we're really adding some interesting pieces. Now one more thing I wanted to mention is that we do no longer have the WIN software. It has been replaced by Keytrain. At one time we thought we might be able to keep both, but I got an email yesterday from Darlene Thompson at the Governor's Office of Workforce Development stating that WIN was gone as of, I believe, it's December the 19th. Is that correct? So we now have Keytrain. Now, does everybody have their access codes to get back in Keytrain just like we used to? So everybody's pretty familiar with Keytrain. Keytrain is good basic skills software. And that is going to be, what I want you to have is I want you to have a variety of tools in your tool bag that you can pull out and use to help students. Well, Keytrain is going to be one tool in the tool bag. ITTS is going to continue to be a very important tool because everybody agrees that it's an effective instructional software. Aztec, we hope, is going to add that last kickstart that our students need to get them ready for the GED. And hopefully the Think 60 that we're previewing now, if it proves out, will be another resource that we can add to our tool bag. Well, at this time, we've got a very, very special treat. As far as I know, this is the first time we've had an outside presenter to come in and talk to us. And we're very fortunate today to have one of our college instructors, Ms. Paige Scott, and she's going to come and tell you a little bit about how she works with her students at the same level of math that we're going to do. Paige?
I appreciate y'all letting me come today. I know it's always exciting for me to see people teach things different ways. Sometimes watching a different method of how to teach a basic skill like factoring, which is a huge skill. Watching people teach it a different way sometimes helps. Mr. Sims gave me like 5 topics that I don't know if you as a whole are having some issues on teaching or need some review on teaching some. We chose factoring and quadratic equations to do today, and there's some, I think that we're going to do some multiple presentations at y'all's meetings and try to get every time, try to give you some more skills on some topics that you're having some issues with the GED test. I will say that I have looked at that Aztec software that Ms. Parrish just showed you guys, and it's a really good software. That's not the software we use at CACC, but I looked through it using the audio and watching the visualization of how those problems are worked out. I think that you're going to see some success with that software. I thought it was a good software math-wise. Now, I didn't look at the English or anything like that, so I don't know anything about anything besides math. So, but what we're going to look at today is we're going to look at factoring and quadratic equations. In the meeting we had last Thursday, they told me that you guys like to see some word problem type things. So at the end of this, there are a couple of, there are like three, they're really science-based questions, but science and math go together. They're, I would say, rather difficult. They would be difficult for my students. Maybe not my Wood 12 students, but my 100 students or 98 students. But I did want you to see those on how, you know, my students, I get the question all the time, where am I going to use this in the real world? You know, I get that all the time. And sometimes I say, you're not, you know, unless you're me, you're not going to use it. But this is, I kind of give you to where you can tell students that, you can look at that, and you might, I don't know how your science GED test is, you could come across something like this. So I do have some problems at the end, some word type problems. Okay, so I put factoring and quadratic equations together because when you're solving quadratic equations, most of the time you're going to be using factoring to solve them. So I'm just going to go through, I'm going to show you just how I teach my class factoring. I definitely use a different method, so if they use the Aztec software and it teaches them how to factor a trinomial, it's not going to be the way that I'm teaching you. Because I've had really good success at the high school level and college level teaching with this method that I call the box method on teaching factoring trinomials. Okay, you might like it, you might not, but my students tend to like it because they tend to remember it because it's a box. Okay, you know, I don't know why, but they do. Okay, so first of all, I've got, if you're looking at that, this handout that you have, I've just got some notes. These are the notes that I give my students that we go over. Anytime the directions say to factor, we go through a series of questions. Because according to what the polynomial is, if it's got 2 terms or 3 or 4, depends on the type of method we're going to use to factor it, okay? Now, before I teach factoring, we teach multiplying polynomials. So I think that it's a good idea because when you say factoring, they say, what does that mean? So we teach factoring first, multiplying first. The full method or the distributive property, however it is that you remember that. I teach the distributive property more than that FOIL, because if you have this multiplication problem here, the full method doesn't work because the full method is for 4 terms, 1, 2, 3, 4. Here you've got 5 terms and they're like, okay, whoa, I don't know how to do the full method because there's 5 terms. So I teach just the distributive property. So before I do factoring, we do multiplying to try to show students that after, now if I get to a point where you have a question, make sure that you stop me and ask me. But we go through this process first so I can tell them, we just learned how to multiply polynomials. Now we're going to learn how to factor polynomials. They gave us this problem, we multiplied, we got this. Now they're going to give us this problem and we're going to break it down and get this. Okay, so I think it's important for them to understand why are we doing this, what does factoring mean. Factoring is similar to division is what I tell them. Because if we multiply and we get this, then we'll factor and get back to this. So it's breaking it down. And I explain factors. If you ask a student what the factors of 12 are, they can probably tell you 12 and 1, 6 and 2. 3 and 4, right? Factors are 2 numbers that multiply together to give you that number. Well, we're doing the same thing here, we're just using polynomials. What 2 polynomials can I multiply together to get this one? Okay, so it's the breaking down process. So I first start with that and trying to explain to them what does factoring mean in general. Okay, so because a lot of times I tell students that reading the directions is half the battle. Especially if you get on a comprehensive test like the GED or the ACT or even a final exam. If you don't know how to read the directions and what they're asking you to do, there's no way you're really going to know how to start the problem, okay? So we talk about factoring first, the actual terminology. So I tell them to read the directions. If it says to factor, then we will simply factor and then stop, okay? Meaning when it says to factor, our answers will pretty much end up in parentheses. Now the difference in that and the quadratic equations, which we get to in a few minutes, is the directions will say solve if they're wanting you to solve the quadratic equation. You will have an equal sign. If you have an equal sign, you're going to solve. I tell my students, anytime you see an equal sign, you're going to get an actual answer like x equals 2, x equals -4. Okay? If it just says to factor, it's just wanting you to break it down and quit. Okay? So understanding the difference between factoring and solving. And I've got you some examples on here of that. Okay, so here's the checklist that I go through with my students, and I'm going to look at this, and we're also going to reference we're going to go through some GCF problems when I ask that first question, so we're going to kind of toggle in between both of these worksheets that you guys have. So the first thing I ask myself is there a GCF? Now, I looked up this part on the Aztec software. They go into really good detail about what GCF means. There's tons of practice problems on finding the greatest common factor. So I tell my students, if the directions say to factor, the very first question you always ask yourself is there a GCF? Okay, because if there's a greatest common factor and you do not take it out, you will not get the correct answer. Okay, you have to take out a greatest common factor. So I'm looking at this first one on your practice problems. It says 5x squared plus 30. And the directions say to factor. Well, what I make my students do is we literally just ask ourselves a series of questions every single time. They go over here to the side and they ask themselves, is there a GCF? That's the very first thing I always ask my students always ask when they're looking at this problem. So what I'm asking for is there a number and or a variable that will divide into both terms evenly? Okay, sometimes there's just a number, sometimes there's just a variable, sometimes there is neither. So is there a number and or a variable that will divide into both of those terms evenly? Yes or no?
Yes.
Yes, and it is 5. Good. So I take that 5 out and I'm going to divide it. When I take a 5 from a 5x squared, I'm left with x squared. When I take a 5 from a 30, I'm left with 6, right? This is division. Good. So we just go through some basic GCF problems from the very beginning, okay? I also make sure that students that the nice thing with factoring is that you can always check yourself because it's the opposite from multiplying. So I tell my students, if you have a question on whether you did it right or wrong, then go through and just check it by multiplying. When you see a number outside the parentheses, you distribute it inside. 5 times x squared is 5x squared. 5 times 6 is 30. And that's what you started with, so you know you got that GCF right. Okay, so I make sure I tell my students you can check every problem on the test. You know, 97% of them never even think about checking, but they do. All right, so let's look at the next one. I've got another GCF problem for you. All right, 16x to the 5th minus 12x to the 4th plus 4x cubed. Now, I will say that my students usually they don't really have any issues on pulling numbers out, right? Noticing that the 5 was the GCF. Numbers don't really give them much of an issue, but for some reason, variables do, okay? Finding the GCF when there's a series of variables sometimes give my students issues. So, the directions say to factor here, so the first question I ask myself is there a GCF? So I'm asking, is there a number and or a variable that will divide into every single one of those terms evenly? Okay, and what's the number? 4. Students always do really good with that. The numbers are not really an issue. For some reason, the variables are. So I have an x to the 5th, an x to the 4th, and an x to the 3rd. Now I tell my students, if all terms have the same variable, you know you have a GCF. Okay, we just got to determine what is it. Because it's got to be the greatest common factor, not just a common factor. So the greatest common factor between x to the 5th, x to the 4th, and x to the 3rd is x to the 3rd. That's right. And sometimes I have to show my students, like I'll break this down right here and show them that x to the 5th literally means you have 5 x's. And x to the 4th literally means you have 4. And x to the 3rd literally means you have 3. So how many could I take from all of them? And I can take 3 from all of them. And sometimes showing that they know if you say 2 squared, that's 4, and 3 squared is 9, but for some reason when you throw a variable in there, it throws them off because it's letters. Why are there letters in math? You know, you get that. So let's take a 4x cubed from every term and see what we have left over. All right, when I take a 4x cubed from a 16x to the 5th, I'm left with 4x squared. Good. And now obviously before I teach this also, we do those rules about division. When you are dividing variables, you subtract their exponents. So that's an important skill they have to have there for that to make sense. When I take a 4x cubed from a negative 12x to the 4th, I'm left with negative 3x. Good. And when I take a 4x cubed from a 4x cubed, 1. Students want to say nothing, gone, disappeared, right? But I make sure that I explain to them that when you check that, it's got to come back to what you started with. And if you lose that term there, then you will lose that term in the check process. Okay? So they want to, you know, when things cancel out, they think that they're gone because we just say cancel, not really that anything divided by itself is 1.
If you talked about the properties, you could also say any number divided by itself equals 1 for that.
Right, and that's the problem. No, that's absolutely correct. The problem is we see things like when we're reducing basic fractions, something like this, we say it cancels, and they think it disappears, right? When it doesn't disappear, it's that it's 1, right? But we say, and I'm guilty of it too, I say cancels, it's gone, right? Instead of explaining that is 1. So where when we get to this here, they want to say it's gone, okay? But them understanding that check process helps that so they can see that that has to be there. Okay, so go through GCF first, and that's the first thing, like I said, that goes through on the Aztec software when it's talking about factoring, they go through GCF. All right, then the second question that I ask myself when we are factoring is how many terms? Okay, are there 2 terms, are there 3 terms, are there 4 terms? Because according to how many terms it's how you are going to determine what method you are going to use to factor. So if there's 2 terms, it's going to be a special case. It's either a difference of squares, a sum of cubes, or a difference of cubes. Now, I did look through the Aztec software and in that booklet that you gave me, and I didn't see any sum or difference of cubes that they asked on the GED test, but I put an example on here just in case. I didn't see any of that, but we'll go through one of those just in case. Now, 3 terms, which is the one you're going to see most often, is this box method, which is the method that I've had some success with on teaching how to factor trinomials. And then with 4 terms, teach regrouping, okay? And the box method works with 4 terms also. All right, so let's look at number 3, and I'm going to go through this box method with you and try to get, see what questions we have and that kind of thing, and see if you think it's any easier than what you teach now when you're teaching to factor. All right, so the directions say to factor. So x squared plus 6x plus 8. I tell my students we go through that same series of questions. The first question is there a GCF? Is there a number or a variable that I can take out of all 3 of those terms? Yes or no? No. All right, so the second question I ask myself is how many terms? And I make them write this every single time. If you look at their test with factoring, there's these questions all over the place. Because if they do the same thing over and over and over, they're more likely to do it when they see it on a test or later on or something like that. So how many terms do I have in this polynomial here? 3 terms. And when we have 3 terms, we use the box. And I have them write it out every single time. If there were 2 terms, they'd write special case. If there were 4 terms, they'd write grouping. Okay? Now, this is how I use the box. Like I said, this is not going to be, the process looks a little different, but it's the same thing that you guys used to teach factoring, a trinomial. So the first thing I do is, like normal, is I multiply the leading coefficient and the constant, the number in front of the x squared term and the constant together. I don't know where that went. It's okay. All right, so I multiply 1 times 8. So I'm looking for 2 numbers that multiply to give me 8, but that add to give me this center number right here, which is a positive 6. Okay, I'm looking for two numbers that multiply to give me 8 and that add to give me a positive 6. 2 and 4, that's right. Now, if they do not know their multiplication tables, which some of my students do not, then this is an issue, okay? We don't let them use a calculator. In 098 developmental courses get no calculator. Once they get to a Math 100, they get in a 4 function. So what my students, some of them have to do is they have to go over to the side and list all the factors of 8, 8 and 1, 2 and 4, right? And that's it, but they have to go over and list those. And as these numbers get harder, this process gets a little more difficult. So this, I tell my students that this process here, finding those two numbers, is the hardest part of the whole factoring concept. Okay? It's finding the two numbers that multiply to give me 8 and add to give me 6, or whatever the numbers are. We'll do it in the dark. Just kidding. Probably can't see. Okay. I'll wait back up. Okay, so from here, what I do is I just draw a box. Okay? Now, I will say, well, let me just finish this and then I'll say that afterwards. Okay, so I draw a box and split it into 4 little things here. All right, so this x squared term goes in the top left, always. The constant goes in the bottom right, always. Okay? And in the other two boxes go your two numbers that you just found. Okay? It doesn't matter which one goes where. You can put 2 here, 4 here, or you can put 4 here and 2 here. It doesn't matter. So I'm going to put 2 up here, 4 down here. Now you do have to add a variable in there with those, and whatever this middle variable is the variable that goes here. Okay, if that was a y, it'd be a y. If that were a t, it would be a t. If it were an xy, it would be an xy. Now from here, we use the greatest common factor. Okay, we're going to find the greatest common factor going down, down, across, and across. Okay, so let's go down first. What does x squared and 4x have in common? What's the greatest common factor? X. And what about 2x and 8? Greatest common factor? 2. And across, x squared and 2x? X. And what about 4x and 8? 4. Now, I tell my students before you put any signs, if they're adding or subtracting, before you put any signs, you go back to these two numbers. And you notice that both are positive. So both of these are positive. So my two factors are down and across, x plus 2, x plus 4. Now, I do realize that when the leading coefficient is 1, whatever these two numbers are going to be the two numbers in your factors. Okay, you don't have to do the box method. But I teach the box method across the board, and then once they get a good grip on factoring, I tell them, if this leading coefficient, this number in front of the x squared term, is a 1, you don't have to do the box, because whatever your two numbers are going to be the two numbers in your factors. But if this is a 2, 3, 4, 5, 6, anything bigger, you must do the box method, okay? Because you can't just find those two numbers and plug them in and it work. So I teach the box method across the board, and then when they get to a certain level to where they're factoring well, then I tell them that little tidbit of information if they haven't already figured it out, okay? All right, so let's look at any questions about this before we look at another one. We start out with some simple ones, and then we'll get to ones that the whole reason I don't use the box per se so much for problems like this. When the problems get a little harder, the box is a lot more efficient. But I teach my beginning students the box from the very beginning, okay? All right, let's look at x squared minus 5x plus 6. X squared minus 5x plus 6. Notice the directions simply say to factor. There's no equal sign. It doesn't say to solve, so we're just going to factor. Our answers will be in parentheses and stop. So I ask myself that series of questions again. I ask myself, is there a greatest common factor in that trinomial? A number or a variable or both that I can take out of all 3 terms? No. So then I ask myself, how many terms do I have? 3 terms, and when I have 3 terms, we do the box. All right, so I start with doing my multiplying. Okay, I'm multiplying my leading coefficient and my constant. So I'm multiplying this understood 1 times 6. So I'm looking for two numbers that multiply to give me 6, but that add to give me negative 5. You have to take the sign with that center number. So the two numbers that multiply to give me a positive 6, but that add to give me a negative 5. What are those two numbers? Negative 6 and 1. Let's look at negative 6 and 1. If you multiply negative 6 times 1, what do you get? Negative 6, right? That's got to be a positive 6. Okay? What else? That doesn't work. What's another one?
Negative 3, negative 2.
Negative 3, negative 2. If I multiply negative 3 and negative 2, I get a positive 6. If I add negative 3 and negative 2, I get a negative 5. That's right. Those are your numbers. Okay, that's the hardest part of finding those numbers. Especially when they see 6 and 1 and they think some version of that's going to give you a 6 and a 5 when you add or subtract it. But make sure that, check those. So I found those two numbers, so I do my box. X squared goes in the top left. The 6 goes in the bottom right. And then the two numbers I found go in the other two boxes. Doesn't matter where you put those. I'm just going to put the negative 3 up top and the negative 2 on bottom. And then I add my variable in with it. We're dealing with x's here, so I add an x in with both of those. So then I do greatest common factor, down, down, across, across. So the greatest common factor between x squared and negative 2x, x. Between negative 3x and 6, 3. Students tend to want to put 2 right there because they see 3 and 6 and they think 3 times 2 is 6. So make sure I have to go through multiple times and make sure that they understand that we're trying to find what will divide into both of those evenly, right? 2 does not divide into 3. Across the top, x squared and negative 3x, x, and negative 2x and 6, 2. So before I do any signs, I make them go back to their numbers here, and I say, what do you notice about those numbers? Not about which one's positive and which one's negative, just how many positive, how many negative. Both of these are negative, so both of these will be negative. So, x minus 3, x minus 2, or x minus 2, x minus 3. Okay. All right, so on these next two especially, this is where the box method, this is why pretty much the box method was discovered, I guess, is when the leading coefficient is larger than 1. So on number 5, 3y squared, sorry, minus 20y plus 28. Okay, in the direction say to factor. Now what you notice about number 5, that was not the same as 3 and 4, is that the leading coefficient is bigger than 1, okay? So you must do some method, whether it's, a lot of people do regrouping. I was taught regrouping when I was in high school. Whatever method it is that you learn, there definitely has to be some type of method used here when that number right there is bigger than 1, okay? You can't just find those two numbers and plug them into the factors. It doesn't work. Okay, so this is why I like the box method is a problem like this. Now this is where you're probably going to need your calculator. Maybe. You might be better at your multiplication tables in your head than I am. Okay, so I asked myself, is there a GCF between 320 and 28? No. I have 3 terms, and so with 3 terms I'm going to use the box. So I'm just going to multiply. 3 times 28 is 84. So I'm looking for two numbers that multiply to give me 84, but that add to give me negative 20. Now with my students do not know, I don't even know what that is off the top of my head, okay? So with my students, I tell them, well, my Math 100 students get a 4-function calculator, but then I have to explain to them, I say, okay, so use your calculator to try to find the factors of 84. Well, then we don't really even know how to find the factors of 84 using our calculator. So I go through with my students and say, okay, let's list all the numbers that multiply to give me 84. So we know 84 and 1. So then I have to explain that if you do 84 divided by 2 on your calculator and you get 42, then 42 and 2 are more factors of 84. Now your students might be better at calculators than mine are, but mine are not very good. Okay, they want them, but they don't know how to use them. All right, so 84 divided by 3, 28, so 28 and 3. 84 divided by 4. And I try to make them go in some type of sequential order when dividing, because if not, they just randomly get all these numbers from all over the place and they miss the one that works. So 21 and 4. 5 doesn't work because it goes 16.8. It's got to go evenly. 6, 14, and 6. Now, when I have a big number like this, and we go through these, I didn't say it with you, but what I tell my students is when I get 84 and 1, I ask them, is there any way I can get a 20 when I add or subtract 81 and 4? They say no, so I know that one doesn't work. Well, then I go 42 and 2. Is there any way to get a 20 if I add or subtract? No, I add to get 44, subtract, I get 40. No. 28 and 3, any way to get a 20 if I add or subtract? No. 21 and 4? No. And then 14 and 6? Yes. So I make them, they can stop there, so they don't have to keep finding all the factors. Once we find the one that works, we stop. Now, we've got to deal with signs here. It's got to multiply to give us a positive 84, but it's got to add to give us a negative 20. What are the signs of our numbers? Negative 14, negative 6. That's right, because a negative times a negative is a positive, and a negative plus a negative is a negative. Now, my students have issues with that because we have issues with adding and subtracting and multiplying positive and negative numbers. Okay, so there's a battle. That's why I tell them that finding those numbers are the hardest part of the process, because you have to use all those adding and subtracting and multiplying and dividing positive and negative numbers. Okay, so from here, I use my box here. All right, I put 3y squared in the top left, 28 in the bottom right. Then those two numbers that I found go in the other two boxes. The order doesn't matter, so I'm going to put a negative 14 and a negative 6. And y is my variable here, so I'm going to add a y in with both of those. Okay? Then I'm going to do GCF, down, down, across, across. So 3y squared and negative 6y, the GCF. 3y squared and negative 6y. 3y. 3 goes into both of those, so does y evenly. 14y and 28. 14, a lot of students want to put 7 right there, right? Because they know 7 goes into 14 and 28. But I tell the students that it's the greatest common factor, right? 7 is a common factor, but it's not the greatest. So we go through another conversation about greatest common factor right there if we get a 7. All right, across the top, 3y squared and negative 14y. Just y, that's right. And negative 6y and 28. Good. Then I look back at my numbers. Now, I will say that I don't, and I hope that I have one on here that does, I do, so we'll have that conversation in a second. All right, so I look back at those numbers, and both are negative. So both of these are negative. So I have 3y minus 14 and y minus 2. Questions there? Okay, I'm going to see if you can try number 6 without me, and let's see how far we get, if we get stuck somewhere to where I can try to help.
I have Tylenol if you might need it. That's what you did, you
Okay, if you're working, keep working, but I'm just for time's sake, I'm going to go ahead and start. So I asked myself if there was a GCF and there is not a number or a variable that will go into all of those terms. So then I look at the number of terms, and I have 3 terms, so I know I use the box method. So I multiply the leading coefficient and the constant, and I get negative 24. So I'm looking for two numbers that multiply to give me negative 4, but that add to give me a negative 10, which is that middle term. And what are the two numbers that multiply to give me negative 24 and add to give me 10, and it's not 6 and 4? 12 and 2, and the negative 12. That's right. 6 and 4 obviously is one that people want to use because 6 and 4, some version of it gives you 10. But if there's no way to get a negative 24 and a negative 10 with a 6 and a 4, whether both are negative, both are positive, or one of each. Okay? So it's negative 12 and positive 2. Okay, that part there is what tends to be the most difficult part for students, are finding those two numbers. Okay? So then I fill out my box the rest of the way with those two factors. And then I'm going to do GCF down, down, across, across. So the greatest common factor between 8x squared and 2x is 2x. Now this case right here is the whole reason that I prefer the box over any other method. Negative 12x and negative 3, what do they have in common? A negative 3. If they both have a negative, you take out a negative. Okay, this is the reason why I prefer the box here. Now, 8x squared and negative 12x, GCF? 4x. And what about 2x and negative 3? 1. Right, if they have nothing, they have a 1. Okay? Now, I look back at my two numbers and I notice one is positive and one of the numbers is negative. So I'm going to have one that's got a plus sign and one that has a minus sign. Well, this one already has the minus, so you know this one has the plus. That's the reason why I prefer the box method right there. It's not what to do where, is half my battle that I have in my classes. All right, so I'm going to go ahead and do the box right here. I'm going to put a negative 7x and a 2x in my box. And then I'm going to do GCS down, down, across, across. So x squared and 2x, the GCF is x. Negative 7x and negative 14. Negative 7. All right, they both have a negative, so I take out a negative. If both have a negative, take out a negative. X squared and negative 7x. X. And 2x and negative 14. 2. Good. So I look at my numbers and I have one that is positive and one that is negative. So I will have one minus and one plus. This one is already minus, so you know this one is plus. Now, don't forget your GCF as part of your answer. X minus 7, x plus 2 should be your final answer. Okay, questions there? One that has a GCF? Okay, I want to make sure that I put one like that on there. Now the next three are, or the next four, are polynomials that only have two terms. And I did see when I was looking through the material that I was given that you do have difference of squares that pops up. I didn't see difference of cubes and sum of cubes. But that might not be true because I think that y'all said that y'all wanted me to do difference in sum of cubes. I didn't see it, but that doesn't mean I don't have the test or anything. I was just looking at that little tutor guide and stuff that you guys gave me. So I'm going to give an example of all of those special cases just so you'll have one to reference here. So let's look at x squared minus 4. The directions say the factor, and I'm going to ask myself those same series of questions. And the first question I ask myself is there a greatest common factor? Is there a number or a variable or both that it can go at, that I can take out of both of those terms? No. So then I ask myself, how many terms do I have? I have 2 terms. So if I have 2 terms, I've got to check to see if it's a special case. Okay, and there are 3 special cases. I've got those listed there. There's a difference of squares, a difference of cubes, and a sum of cubes. Those are the only 3 ways that we can factor a polynomial that has 2 terms. Okay? So I look at this one, and so I'm thinking of those special cases in my head that I know, and I notice that this is a difference, Okay, so that already marks out sum of cubes because difference means subtract. And then I've got a difference of squares and a difference of cubes. Now squares meaning both the numbers are perfect squares, meaning you can take the square root of them. Difference of cubes meaning both are cube roots, which students struggle with cubes a little more than they struggle with squares. So I look at this, and this is x squared and 4, and both of those numbers are perfect squares. Okay? So what I tell my students from here is I open up 2 sets of parentheses. Okay? So I tell them, you told me that they were perfect squares, so what is the square root of x squared? X. So that goes in the first term of both of those parentheses. And you said that 4 was a perfect square also. What's the square root of 4? 2. And signs are 1 of each. Right. And I go through, and when I first teach this, is I go through the check process on this one to make them understand why there's 1 positive and 1 negative, because those center numbers will cancel when you go to multiply through. Okay? And we've done multiplying before, we've done factoring, and so they've seen ones like this, but they don't really see the connection between the factoring part of it when they're doing the multiplying. Okay? All right, so difference of squares. Students usually do fairly well with difference of squares because they know square roots relatively decent. All right, so let's look at the next one. X squared plus 16. Okay, so I asked myself the same series of questions. Is there a greatest common factor between x squared and 16? No. All right, how many terms do I have here? 2. So I've got 3 special cases that it could be. A difference of squares, a difference of cubes, or a sum of cubes. So the first thing I look at is that sign, and that sign is plus. So the only one it can be is sum, right? So that knocks out difference of squares and difference of cubes because that is not a difference, right? Difference means subtract, plus means sum. Now, is it a sum of cubes, meaning both of those terms are perfect cubes? Yes or no? Cubes, not squares, cubes. Meaning you can multiply the number by itself 3 times. No. That this is prime. Cannot factor it. Okay, cannot factor if it is a sum of squares. Not possible. Okay? Now, I get x plus 4x minus 4 on this all the time, right? Because they think it's a difference of squares, okay? But it's got to be a difference of squares. So we go through those, what those words mean, difference, sum, that kind of thing. All right, and the next 2 here is I've got you a difference of cubes. Now, this one is a little more difficult in nature. And now we give our students, I should have looked and now I didn't, on that formula sheet that your students get. I don't know if they get this formula. We give our students this formula on the final exam on how to factor this, but I don't remember if this was in your formula, in that formula sheet. All right, so ask yourself, is there a GCF first? Yes or no? No? All right, and there are 2 terms, so we've got to check to see if it's a special case. So we know it is a difference, so it's either going to be a difference of cubes or a difference of squares, okay? So, is x squared a perfect square or a perfect cube? Cube, right? Because x times x is x cubed, right? So it's a difference, is 27 a perfect cube? Is there a number you can multiply by itself 3 times and get 27? And it is 3, okay. So from there, I tell my students, you open up a small set of parentheses and a large set of parentheses. Small and large. Okay, so from here, you said that x cubed was a perfect cube, right? What is the cube root of x cubed? X. Good. You said 27 was a perfect cube. What's the cube root of 27? 3. All right, that's a minus there. So this is a minus here. Okay. Now, to find the 3 terms that go in your second set, we're going to use these numbers here. Okay. So, and you might need to make yourself some notes of, what this is if you don't already know how to do this one. So you take that first term and you square it. So what's x squared? That's not a trick question. X squared, okay? Then to get this center term, you multiply these two numbers together, ignore the sign. I'm just talking about x and 3. What is x times 3? 3x. Okay? Then you take the last term and you square it. What is 3 squared? 9. Now, let's talk about the signs. This sign is always a positive. Always. Okay? Even if that says sum, it's still a positive. This is always a positive. Okay? And this sign is opposite this sign. So if that one's minus, this one is plus. If that were a plus, this one would be a minus. Okay? And you just factored a difference of cubes.
Can you tell us that second parenthesis again?
Yeah. Okay? You're good with this one?
Yes.
Yeah? Okay, to get the first term, you take the first term here and you square it. So x squared is x squared.
Okay.
To get the middle term, you take these two numbers, ignore the sign, doesn't matter if that's a minus or plus in between, and you multiply those together. X times 3 is 3x. Then you take the 3, the last term in that first set of parentheses, and you square it. 3 squared is 9. This sign is always a plus. This sign is opposite this sign. Okay? All right, let's try another one. The next one is a sum of cubes, so it's going to be the same process here. Whoop. Sorry.
So what happens if up there you have x cubed plus 27?
That's what I'm doing next.
Oh.
I'm doing a sum of cubes. Same process, it's just the signs will be different. Yeah. Are we okay with this now? Okay.
Yes, ma'am.
Okay. All right, so let's look at 64x cubed plus 8. Now, I know that the process of doing difference of sum of cubes is not the easiest process, but before you even get to that point, my students do not recognize perfect cubes very well. Okay? When they look at 64, they do not know that 64 is a perfect cube. So we have to go through that battle first. And I make them make a list of all the perfect cubes. They can't use it on their test, but if they'll have that list and they use it when they're studying, then hopefully they'll recognize those. You know, I tell them, I don't know a ton of them, but I know up to about 7, and you're not really going to have much bigger than that. We don't. So I don't know if y'all will or not, because y'all's test is harder than our test. Okay? So I do make them make a list of those perfect cubes because we have to get to that point. They have to recognize perfect cubes before they even know how to factor something like this. Okay, so I go through that series of questions. I'm mad because this has GCF and I didn't want it to. Okay, let's change this 8, okay? Let me change this 8 to something else. Let me change it to 125. Okay, sorry, that had GCF and I did not want that to happen. Because it wouldn't factor anymore if it, yeah, sorry. Okay, so I asked myself, is there a GCF? No. And there's 2 terms, so it's going to be a special case. All right, or we're going to check to see if it's a special case. It could be prime. Okay, so I've got to check to see. There's 3 special cases. If it's not one of those, it's prime. So it's a sum. So the only option I have is, that's not there, you're looking on your paper, is sum of cubes. Okay, so are both of those terms perfect cubes? Yes, and I tell my students, don't just say yes because I asked, right? Is it really like perfect cubes, right? Because I'm going to ask you what's the cube root, you know, and then they'll just sit there and look at me, and I'll say, well, you said it was. So, but both of them are perfect cubes. All right, so open up a small set of parentheses and a large set of parentheses. Okay, so I do the small set of parentheses first. You said 64x cubed was a perfect cube. What is the cube root of 64x cubed? 4x. Good. Okay. You said 125 was a perfect cube. What's the cube root of 125? 5. Good. And this sign here, plus, it's the exact same as the original problem. Okay. Now, To find the next 3, I'm going to use this small set of parentheses, okay? So I take that first term, which is 4x, and I square it. What's 4x squared? 16x squared. Good. My students want to say 4x squared right there. Okay, they forget to square the 4 also. Okay, then, I know this is an inconvenient angle for you. Okay, so then I take these 2 terms and I multiply them together. Ignore the sign. 4x times 5. 20x. Okay, then I take the last term here, which is 5, and I square it. What's 5 squared? 25. Good. Okay, then I deal with my signs. This sign is always a plus, always. And this sign is opposite this sign, so it is a minus. Good. This sign's always a plus. Last sign's always a plus. And then this sign's opposite the first sign. And I determine the first sign because it's the same as the original problem. Okay, Bert, can I have like 3 minutes? Okay. I do want to do a quadratic, see, and that was one of the things I was supposed to be doing. So I definitely want to do the solving the quadratic. Questions about difference of sum of cubes? The formula's not easy. We do give them the formula on ours. I don't know if you guys, did you know if y'all give the formula? We don't give the formula, so they just have to know that. Okay, like I said, I didn't see any of those on here on the paperwork I got, but I figured there might be.
We do have a formula for the quadratic, right?
Okay. All right, so let's look at x squared plus 6x plus 8 equals 0. Now, I make sure that I explain to my students at this point that the difference in this problem and the problems we have seen before is that this has an equal sign, okay? This is a solving an equation, okay? So at the end, if the directions say to solve at any point, at the end, you're going to get x equals something, okay? If it says to factor, we just factor in our parentheses and we leave it. This has got an equal sign, so we're solving, so there's going to be an extra step here, okay? Now, there are multiple ways to solve quadratics. One is the quadratic formula, the negative b plus or minus the square root, all that business. You can definitely do the quadratic formula. I tell my students, you can use the quadratic formula on any quadratic. Anything that has an x squared, you can use the quadratic formula, okay? Or you can also factor. Use the box method and then take it that step, the next step, okay? Now, do you want to see me do the quadratic formula and factor, or do you have a preference? Both? Okay, all right, let's do both. All right, so I'm going to factor first, and then I'll show the quadratic formula, and I'll see that we get the same answer both ways, okay? All right, so I'm going to factor first, and I tell my students we factor so much that they prefer factoring over quadratic formula if it factors. Now, I do explain to them that when you do this business and you multiply, sometimes you will run across a case where you cannot find 2 numbers that multiply to give you blank and add to give you blank. And if you can't find those numbers, you always use the quadratic formula, okay? And then I have some students that prefer the quadratic formula and they just use it all the time if it's got an equal sign, okay? But the issue I get with is when I give them a factoring problem, they want to use the quadratic formula. You can only use the quadratic formula if it's a solving an equation problem. It must have an equal sign to use the quadratic formula, okay? So that's where the issue, they don't really get that concept. So that's the issue that I battle here. So I'm going to use the box method over here, and then I'll go over here and I'll use the quadratic formula so I can show you how to use both. So there is no GCF, okay? There's 3 terms, so I'm going to use the box method. So I'm going to look for 2 numbers that multiply to give me 8 and that add to give me 6. So this is a relatively easy one. So what are 2 numbers that multiply to give me 8 and add to give me 6? 4 and 2. Good. Okay, so I do the box here. And I have x squared, 8, 4x, and 2x. All right, so I'm going to do GCFs, down, down, across, across. So x squared and 2x have a x in common. 4x and 8, what's the GCF? 4. Students want to put 2 right there, put 4. Across the top, x squared and 4x, x, and 2x and 8, 2. Good. So I look, and both of these are positive. Both of those numbers are positive, and that tells me the signs that's going to be inside my factors. Since both are positive, both are positive. Okay? So I have x plus 4, x plus 2 equal 0. It's still equal to 0. Now from here, this is called the zero product principle. Okay, my students do not know it's called the zero product principle, but that's what it's called. And what it says is once you have factored a polynomial, you factored it, you can set each one of those factors equal to 0 and you will get your 2 answers. Now I do explain to students, they ask, how do you know you get 2 answers? It's because if that is a 2, then that tells me I'm going to have 2 answers. The highest exponent, which is called the degree, whatever that degree is how many answers you'll get when you solve it. If it was a cubic, I get 3 answers. If it was to the 4th power, I get 4 answers. Okay? So I know I'm going to get 2 answers here. So I'm going to set each one of these equal to 0 separately and solve. So I'm going to set x plus 4 equal to 0. And I'm going to set x plus 2 equal to 0. Okay? And I'm going to solve those separately, a basic linear equation. So, to get x by itself, that's a plus 4. The opposite of plus is minus, so I'll subtract 4 from both sides. That cancels. X equals negative 4. X plus 2 equal to 0. The opposite of plus is minus. I do the opposite to move across the equal sign. X equals negative 2. So there's my 2 answers, negative 4 and negative 2. Okay, so the only difference in factoring and solving is we stopped at this point for factoring, right? The only difference between factoring and solving is we set those factors equal to 0 and find your actual answers. Questions there? Okay, all right, so let's do the quadratic formula on the same problem so we can see that you get the same answer if you use the quadratic formula or the or factoring. So the first thing I do when I'm teaching quadratic formula is I have them list. What is their A, what is their B, and what is their C? Because in the quadratic formula, there's a series of A's, B's, and C's in that formula. So they've got to know what stands for what. Well, the A is the number in front of the x squared term. So in our case, our A is 1. The B is the number in front of the x term. So my B is 6. And C is the constant, which is the number with no variable, and it is 8. All right, so the quadratic formula is, I'll write the formula first, and then we can plug it in. Okay. So now I'm going to plug in my A, B, and my C into that formula. And that formula is on their formula sheet. So I'm going to plug in negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 8 all over 2 times 1. Now there is a way that they can plug this whole thing into their calculator and get the answer. I don't suggest it. It's a mess. If you've got like one of the really high-tech graphic calculators, it's a lot easier because you can plug it in exactly the way it looks, but I don't suggest you doing that. All right, so simplify under the square root first. So 6 squared is 36, and then I'm going to multiply negative 4 times 1 times 8, which is negative 32. Good. All over 2. All right, so I'm still simplifying underneath the root. And negative 6 plus or minus the square root of 36 minus 32 is 4. And I tell my students, You should be really happy if that number right there is a perfect square, because this is going to work out nice. Right? No simplifying roots, anything crazy like that. We want that to be a 4 or a 16 or a 25 or something nice. Okay, so from here I break this into two separate problems. Well, let's go ahead and take that 4 to a 2 first. All right, so I'm going to do -6 plus or minus 2 over 2. I took the square root of 4, and the square root of 4 is 2. So from here, I break this into two separate problems because I have a plus and a minus. And that plus or minus gives us our two answers that we've got to have since it's a quadratic. Okay, since it has an x squared term, that gives us our two answers. So I'm going to have -6 plus 2 over 2. And I'm going to have -6 minus 2 over 2. Okay? -6 plus 2 is -4. Your students know how to use the negative sign on that yellow calculator that you guys use. That negative is down there in the bottom, you know, so they don't have to. Sometimes, yeah, they want to use the minus and it doesn't work. Yeah, that little negative sign. All right, and -4 over 2 is -2. All right, and then I'm using this, working on this one. -6 minus 2, -8. And -8 over 2 is -4. And that should be the same thing we got when we factored and we solved. -2. So it's really just preference. Quadratic formula is my last resort because I don't like it, because I like to factor better, but some students prefer the quadratic formula, so it really doesn't matter. I tell them it's one of the few things they get a choice in, so you choose. Okay, questions there? Okay. Okay, Bert, I got through all the problems. I didn't get to the word problems, but we can save that for another day. Or you want to do it? I'll do one of them. We'll do one word problem. Okay, perfect. Okay. I'm going to do that first word problem, okay? And then there's more. There's 2 more on the back. Okay. Like I said, I've got 3 listed right here, and on this first one, I tried to do some explanation down there at the bottom of where this formula came from, kind of stuff. In the real world, quadratics are used when we're talking about anything being thrown, like a projectile, anything being thrown. There's multiple things we can do. Because when you graph a quadratic, when you graph anything that's got an x squared, it's either going to look like, I say smiley face or frowny face, but it's a parabola. It'll either look like this, or it'll look like this. So anything that's being thrown has this shape, whether it's that high or not. If something's being thrown or dropped, it has that shape. It starts, it goes, it drops, and it has this parabola shape. Okay, so in the real world, quadratics are used when we're talking about projectiles. Okay, so I've got a couple of examples of some. This is a really good, it looks to me like a really good science question. I'm sure it's like on the ACT, stuff like that. I don't know if you guys have seen anything like that. We don't particularly see much like this in our classes, but we don't have a lot of time to go through stuff like this. We need it, but we don't even, there's just no time to do everything that needs to be done. So let's just look through this problem. It says an object is launched from 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, S, at time t seconds after the launch is S of t is -4.9 t squared plus 19.6 t plus 58.8, where S is in meters. When does the object strike the ground? Now they give you that formula. Now they explain to you down there at the bottom, it says that this is the formula. This formula here is the same formula that's used anytime something is being dropped or thrown. Okay, so let's just look at that formula. This formula, the G stands for gravity. Okay, the G stands for gravity. And it says if we're talking about meters, then it's going to be -4.9. If we're talking about feet, it's going to be 16. That's just general information, and that's down there at the bottom. This V naught right here is the initial velocity. Okay? So remember, velocity is going to be in like meters per second or feet per second, right? It's got a distance and a time component with velocity. And then with height, this right here is the initial height. So did they start at the ground and throw it, the height would be 0. But if they started from somewhere up high and they dropped it, then the height would be however tall that building was or whatever they threw it from, okay? So that formula they use over and over and over, okay? So the main thing you have to look at is, are we talking about meters or are we talking about feet? With meters you use 4.9 and with feet we use 16. Now we do use negative because gravity pulls downward, so that is a negative component right there, okay? So let's just look at this first one. They give us the equation, and I'm going to show you how you go through and solve something like this. It ends up being a really simple problem while it looks fairly complicated. All right, so I have S of t equals negative 4.9 t squared plus 19.6 t plus 58.8. Now what you can see is negative 4.9 is gravity. 19.6, it says the object is launched at 19.6 meters per second. That is velocity because it has a distance component and a time component. So velocity goes as that center term, okay, because that's what the formula says. And then it says that it is launched from a 58.8 meter tall platform. So that's the height at which the object is thrown. If it was from the ground, then that would be a 0, right? If you're throwing something from the ground, the height would be 0. Well, it actually wouldn't. It'd be however tall you were, but okay. All right, so 58.8. Now, I want to solve this, and it's saying, when does the object strike the ground? So we're looking for t, okay? Now, remember, when we were solving quadratics, these were x's, and when we factored, we found what x was, and we solved that quadratic. So we're looking for t. When does it strike the ground? So, the first thing that I would do here is I would set that time equal to 0 so we can solve this quadratic. To solve a quadratic, it has to be equal to 0. Now, if possible, this is just in general, you want that term right there to be positive, if you can make it positive. And if you can actually make that term 1, that would be even better. Okay? So what I'm going to try to do is I'm going to try to divide every single one of these terms by negative 4.9. Now the reason why I'm doing that is because if that first term is a 1, it makes this problem a lot more simple to factor. Okay? Now this ends up working out nice. So on your handy dandy calculator, negative 4.9 t squared divided by negative 4.9 is t squared. Okay? 19.6 t divided by negative 4.9 on that calculator is negative 4, right? Because that's a positive and a negative, so you get negative 4. And then on my calculator, I divide 58.8 divided by negative 4.9. Does everybody know how to, do you know how to type in that negative to where it tells you the sign also? Yeah, okay. And what is that? Negative 12, perfect. Okay, now we're at a very basic quadratic, right? I mean, that is very basic. Okay. Now the zero's on the wrong side, but you can change it over if you want to put this. You know that throws my students want it. 0, right? 0 is on the wrong side. That is wrong. So I'm going to rewrite it just for clarity's sake. So that turns into a very basic quadratic. Okay. There are 3 terms. So I will be looking for 2 numbers that multiply to give me negative 12 and that add to give me negative 4. This is just basic, the box method, solving. So what are 2 numbers that multiply to give me negative 12 and add to give me negative 4? Minus 6 and positive 2, right? So you can definitely do the box method right here, okay? Or if let's say we're to the point where we understand that if this number right here is a 1, then you get to write those straight into your factors. Okay, if that's a 1, you can write those straight into your factors, meaning that will be t minus 6, t plus 2, because that is a negative 6 and a positive 2. You get the box method, you're going to get the exact same thing. Just for time's sake, I'm just going to go ahead and write it here. All right, we're still equal to 0. Now, from here, this is the zero product principle. okay? So since that is equal to 0, I can set both of my factors equal to 0 and solve. So I'm going to do that up here just so we can see. So I'm going to have t minus 6 equals 0, and I'm going to have t plus 2 equals 0. Okay, and solve those separately. So t, this is add 6, t equals 6, minus 2, t equals negative 2. Now we need to make sense of the problem, okay? It's saying, when does the object strike the ground, okay? We will not consider any negative time, okay? No negative time. So the object will strike the ground 6 seconds after it's launched. Okay? Questions? Okay, so I'll let you go home and do the other two because I know you're going to be able to do them perfectly. It's going to be great. I will say on that number 15, you're going to have to find the vertex of a parabola.
You need to show us.
Okay. Your cell phone number? Yeah. And then on number 16 works a lot like that number 14 that we just did. Okay. Number 16 definitely looks a lot like that. Okay, 30. Sorry, I'm like 30 minutes over.
This time we're going to move right on into the most missed math problem. David Newman and Linda Parrish are going to share that.
I'll go through this very quickly. They did a workshop for adult ed educators, and they went, the State Department did, the adult education, and they went through some most missed math items so far on the GED. So we thought this might be something just to mention to you. As you teach the math, make sure that you include some type of instruction on these particular items. Okay, we're not going to try to teach them to you, we're just going to show you what a little bit more than just reading the slides.
You know, even though they have a formula sheet and they gotta have the formulas for radius, diameter, circumference and all that, a lot of times students don't understand that as they give you the area, how you get back to find the radius of the circle. Okay? If you're not looking ahead on your sheet, I would ask you, how would you do that? But the next slide, of course, works it out for you. Why didn't it change? There we go. So it's not so much the problem, it's them looking out for what it's asking for, okay? And they just need to change the formula around a little bit to find the answer. So that's one of the big things. Like she said, we're going to do this quick because we hate to follow what Paige just did.
Y'all take your time.
They might ask it both ways. And we know from the Common Core that there are different levels of knowledge. And I think just finding the radius, or finding the circumference is one skill that's basic. But then when you're trying to find the radius, and you have the circumference, it takes it to another level. So I think that's going to be a higher order of learning, and I think that the GED has some of both. So you're going to have to go past just teaching circumference or area.
Or just teaching them what formula does it.
All right, these are some more. It says the most missed items are, and you can read it on the big chart, and you might want to look at it on your big chart when you get it on your computer. But they need to be able to do the perimeter, they need to be able to do the area, and then they need to be able to do the length when given the perimeter or the area. And because it has these particular ones listed, I think you need to make sure you teach perimeter and area on these shapes. The first one is a rectangle, and on your formula sheet that they will get, I think this is given, parallelogram, rhombus, trapezoid, and it calls it a regular n-gon. don't know what an n-gon is, except that this is a hexagon, and it means a regular shape. In other words, the angles and the sides are the same. Okay? And then the next sheet is the formula sheet that you will get for the test. We're also going to send you those in an email so that you can make copies for your class. And at the end of your packet, you have a copy of the formula sheet and a copy of the symbols that they are use. Yes. Yes. And you know, as I was researching the different formula sheets, I saw several. They sent us one, we got this at conference. They gave, did y'all get one of these? It was, one of the companies was giving it out. And then when I pulled it up on the GED website, it didn't look exactly like this. It looked a little different. So, but they all basically have the same thing on them. And then the symbols, this is important down here, because as you do it, they're going to need to know these symbols. They're going to need to know the inequality symbols and plus or minus symbols.
This is another problem they say is most missed. It's not a very good slide. You can see the light shadow there, but it says compute perimeter or area of two-dimensional composite shapes. That doesn't mean just the size of the house. It means the size of the house, windows, doors, everything. And so to me, it's more that the students are not paying attention to what the question is, what they're asking for, rather than actually doing the work. So we need to make sure that they look for the right answer and not just come up with an answer. So, other than that, I don't understand why this one's on there, other than the students not really reading the problem correctly.
And if they've got to learn, they've got to figure all the different shapes and then add them all together to get the entire thing. All right, another thing that they're saying is a problem is scale, comparing this one to this one. And a scale factor means that you have the shape of the small one, and can you transfer that by finding the corresponding shape on the big one, like a scale model versus the real length of something, of a real object. So that's important that we teach them. If the small triangle was a 3 and a 4 for two of the sides, and you knew that one of the side, the corresponding side of the 3 was a 12, could you figure the bottom of the big one? And it would be going from the 4 to the one that corresponds. You would write a proportion. The factory would be the ratio, this one to this one. How much bigger is this one to this one? And then you would write it as a proportion. So teach them proportions, because that would be the way, and they'll have some of those. The Aztec, I did see some problems like this.
But is that what that question's really asking? Because that says the magnitude of the size change. That just doesn't ask for the new sizes. That asks for the magnitude.
And the magnitude would be the ratio.
It's going to be a percent.
Well, it could be a percent.
If it goes from 4 to 8, then you know what percent.
What percent? Yeah. What's the ratio, and then you could get that to a percent. Get it to a fraction.
That involves something more than just the ratios and proportions.
Yes.
Which was on the old test. This is the step up.
Yes. Thank you. Yes, you're right.
Okay, this is another problem that students don't really, they don't look for the bottom answer. Okay, this is a two-step process most of the time. If you have something on sale and it's 20% off, you know, how much is that item? Well, most of the time they'll just get 20% off and think that's the answer. They don't go back and do the second step. So we need to make sure they understand what the problem is asking for. And you know, we always have trouble with students in percent and discounts and all that kind of stuff. So we need to make sure they understand that. We need to teach them those little formulas, which are very simple, really. Matter of fact, I just use a simple formula all the time and let them work it around. Just part number equals a whole number times percent, and that works for every problem, even though you may have to subtract this or add that. So we just need to make sure that they get the bottom answer, not just work the first part of it.
Okay? I think the old test went into coordinate plane and it mentioned slope. Now we're taking it into the things that Paige talked about from this, the equations and graphing and take it further. But people must still be having problems with just locating points on a coordinate plane. They need to know how to find what a coordinate plane is. They need to know how to find points on the coordinate plane, and they need to know also the quadrants, that they need to know that the horizontal is X and the vertical is Y, and what the quadrants are, and how to find points. And then they need to be able to connect points and make a line, and then they need to give you the slope. So we're going to have to make sure that we teach them this. And of course the slope is how high is the line, how steep is the hill. So they need to be able to determine slope. I hope that we can get Paige to come back and teach us about the point slope and the intercept method a little more thoroughly, because the way I learned slope was just to do it by the changing Y over the changing X, which is basically those two other things. All right, they can do it several ways. They can look at the 2 minus 2, 1 and the 4, 3, and find the change in Y over the change in X, and that will give them the slope. Or they can actually count the spaces on the grid, and the top one, the slope is 3, is 1/3, so they could go over 3 and up 1, because it's the rise over the run. Okay? They just need to be aware of all those different
I
things.
think it goes further than that, though, and ask you to look at the grid and pick out the formula or the equation.
Yes, that's what I was just fixing to say. They got to be able to do an equation from it also. They got to be able to work the equation. They got to be able to write an equation for the line. And then they've got to be able to take an equation and find X and Y and make a line. And then graph it. Okay, put it on the graph. So these are things we're going to have to be a little more aware of. The Aztec program again has excellent lessons where they actually do some of these things. So it's really good. Okay, the next one is a problem that David's working out for us. Is that what you're doing?
Yeah, basically.
Okay.
You probably can't see it on your little sheet, but this is the problem they're asking for. And of course, this is just a linear function, right? A linear problem. Got 2 variables. And you can see, let me get over one minute. Hartley opened a food truck business to sell food on the street. On day 2, his business earned $112. Day 5, he earned $367. He assumes the earnings will continue at the same rate. Okay? How much will he earn on day 10? Okay, so what do we know? All right, we know that X1 is day 2, right? So X1 is 2. He earned how much on day 1? 112? Is that what I said? X2 is what? Day 2. Or day 5. So that's 5, right? How much did he earn then? 367. X3 is? No, day 10. Y3, how much did he earn? That's what they asked us to find out. All right, so let's, what do you want to call that? B for earnings? All right. So how do we solve that? Any ideas? Remember, it's a linear equation. There are probably several ways you could do it. One way, and the way I did it real quickly, was just use this slope formula, right? All right, what's the formula for a slope? M is y2 minus y1 over x2 minus x1. Okay, if we plug in those values, we have 367 minus 112 over 5 minus 2. And you work that out, and it comes up to 85. So that's what M is, right? All right? So now let's look for this value. We're trying to find y3. So we put y3 minus y2 over x3 minus x2. And we plug those in. And we have y3 minus 367 over 10 minus 5, right? That comes up, run that around here. That comes up to 425. I'm sorry, I skipped a step. I don't want to do that. That comes up to, because M is 85, it comes up to 85 equals y3 minus 367 over 5. All right, multiplied by 5, and that comes up to 425 equals y3 minus 367. Then we add 367, and y3 is 792. So that's what he earns on the 10th day. You should click the next slide. The next slide is a graph of that. And you'll see it's just a straight line because the slope or the rate is the same. All the time it's constant. So that's one way to solve that problem. I had to think about that a while because it's been a while since I've done that. And there may be another way to solve it too. To me, that's the easy one. Just the old slope formula.
Who knew that slope goes with salary? Just like who knew that the velocity, the gravity, how much it fell, goes with the quadratic formula.
So here's some practical use for all this stuff.
That's exactly right. Okay. I think we're going to have to teach our students to think algebraically. And, you know, when you were in the first grade, you did a box. 1 plus box equals something. Well, that's X. X goes in the box. So maybe we need to teach them to think more in terms of what is Y or what is X to solve problems. A one variable linear equation is just solving, that's a two-step problem. That first one up there is a two-step algebra problem because they've got to add 4 to both sides and divide by 2 to find out what Y is. We need to make sure that's fairly basic. I don't know how much of that I did on the other GED. You know, I touch on it with the smarter students, but they're going to all have to have this test. And then formulas with multiple variables. Well, that goes back into the surface area and the volume and all. That's the formulas, and they're going to have to fill in the variables, the ones they know and the ones they don't know, to find out all the things that we've gone over. Okay, let's go off. Okay, and then solving linear inequalities. And inequality means that it's not equal to it, it is less than, or it is greater than. So they're going to have to be able to solve these. And of course, to solve a linear equality, you pretend like it says equal. You just solve it like it says equal, and then you put the greater than or less than sign back in the answer. So on this one, you would add 5 to both sides, and that would be 2y is equal to 12, and divide by 2, so the answer would be 6. And then, but then it's still less than. It's less than 6. Okay? The only time that would change, and this will be something that you need to make sure you know, is that if your division on the two-step equation is a negative number in front of it, you change the less than to greater than. And I don't think we probably need to even tell them why, just that you change it if it is negative, because that changes the direction, it changes the size of the numbers with the negative number. And then solving one variable quadratic equations with real solutions is exactly what Paige went over. She went over that this is the A and the B and the C that she was talking about in the quadratic formula. They've got to be able to solve, and it says with real solutions, that means there's going to be two x's. There's going to be two solutions for each one, and you can put them in real world problems also. So.
And two, in the real world, there's usually only one answer that works. Like she showed you,
Yes.
you can't have a negative time.
Yes.
Okay. Another problem students seem to have is transferring words into a formula or into symbols. The example I give here, on an algebra test, the lowest grade was 42 points higher than the highest grade, was 42 points lower than the lowest grade. The sum of the two is 138, prime lowest grade. Well, you got to create symbols for that. And of course here they use L, the lowest grade, right? So what's the highest grade? L plus 42. And they add those two together equal 138, and then you solve for your answer. So the problem is translating that word problem into symbols and into an equation that they have problems with.
The next one is the same thing, actually. It says create a one or two variable linear equation to represent situations. And I'm not going to work this, but they worked it out to the side, and you can see it up there. Find x equals the cost for a child and y is the cost for an adult. That's two variables in the same problem. Write two equations that fit the two situations. One is for $162, they had so many adults and so many children, and $122, they had so many adults and so many children. And then you can subtract the two equations from each other and find out what they have in common, which would be like the common factor, and then solve for x and then solve for y, and you'll get the answer to the question. This is taking a word problem like we used to see on the old test even, and making it an algebra problem to solve it. And I just think it would be so much easier for the students if they think algebraically a little bit more. Now, that's a big task to teach you, though. I know that. Is that it?
Oh, along the same lines, it's the same thing, it's just inequalities. Create one variable linear inequalities to represent situations you've been given. Perimeter of a square. Good night. Maybe you can look on your sheet on this one. Perimeter of a square must be less than 160 feet. What's the maximum length of each side? So we just, we know each side is x, and you got 4 of them, and it's got to be less than 160. And you just solve for x. All it is just inequality instead of an equation. And I think a lot of it is they don't understand what the inequality means, more than less than what it's all about. And that's where we come in. That's all the slides, thank goodness we hit it right time. Are there any questions about any of this? Like I say, these are the things that are most missed, so these are the things we need to work on with these students.
Thank you, David and Linda. I think they did a great job. I wanted to share a couple of, we are just about finished, food's ready, we're just about to bless it and go eat it. But I wanted to share a little anecdote with you. The reason I brought these peppermint and chocolate squares with me today is I've heard over the years that peppermint and chocolate help us to think more sharply. And I thought if there's any day we all needed to have our thinking sharpened, today would be a good day. And also what really made me think about it is the other day we had 5 students from Columbiana that came to Childersburg to take the GED test. And And all of a sudden, here Lynn Horton pops up, who's their teacher. And I said, Lynn, I said, what are you doing here? She said, well, I've got 5 students taking the GED, and I brought them some chocolate and peppermint, because I heard that that'll help them to think that they can hopefully pass the test. They weren't scheduled to go in until 10:30, and they'd all gotten there early, and they were all already in, and she couldn't go in and give it to them, but her heart was certainly in the